All right, we're going to do applications of the normal distribution curve using the TI NSpire calculator. So we're looking at this first problem. Pediatrician has 203-year-old female patients. She knows the heights are normally distributed with mu of 38.72 inches and standard deviation 3.17 inches. So we're looking for what proportion of her 3-year-old female patients are shorter than 35 inches. First thing I always want us to do is to draw our normal curve. We have our normal curve. We know that the mean, our middle, is 38.72. We don't know exactly where 35 is, but we know 35 is somewhere to the left of that. And we want shorter than, we want the area to the left. Since we're finding the area to the left, we want to use norm CDF. We want to find the area under the curve. Whenever we do this, we want our lower bound, upper bound, then our mean. So lower bound, upper bound, mean, standard deviation. So our lower bound is negative infinity. We can't write that. We use 9E99. Our upper bound is our 35, our value. Our mean is 38.72, and our standard deviation 3.17. So we type that in our calculator. Our EE button is the double E's here on the left side. 999. So 35 is our value. 38.72, our mean, and our standard deviation. So we have our area. Our area to the left of that value, or from negative infinity to 35, is 0.12, and we'll round it to that. So it's approximately 0.2. So what proportion? 12%. Now, if we're looking for the 20th percentile, this time we are given an area. 20th percentile is below our mean. Again, we know our mean is there. 20th percentile means that 20% of our population, in this case 3-year-old female patients, is below that number. So it's over here somewhere. We don't know the X value. That's what we have to find out. Now we know the area. The area to the left is 0.2. The percentile, change it into a decimal. Since we know the area and we're trying to find a value, we use the inverse function. In norm, and whenever we put this in here, we have our area to the left, then our mean, and our standard deviation. So the area to the left is 0.2, our mean, and our standard deviation. So in norm, area to the left, our standard deviation, and our mean, our standard deviation. So we have our X value, 36.05. So anybody who's 36.05 inches is in the 20th percentile for heights. If we want to find the heights to separate the middle 95%, again, I want to start with my diagram. So I know the middle here is 0.95. Again, I know area. I want to find those two values. Since we know the values or the area of the middle, we can figure out the area in each scale. 1 minus that. We have the area of the other two is 0.5, and we have to cut that in half. The area of each one is 0.2. And now it's just like the last problem we just did. Inverse norm, 0.25. Our mean, 30.72. Our deviation will give us our first X. We do this again for our second X value. And now, again, we want area to the left. The area to the left of this value is 0.95 and 0.025 add up to 975. Same mean, same standard deviation, and that'll give us our x2. So we're just going to change this from what we did before, and we're going to change this from the other one. So 32.5 and 44.9. Those are our two cutoff values. The heights that separate the middle, 95%.